So, hello guys, welcome back to my YouTube channel. So, today let's solve one more lead code problem, which is 236 point lowest common ancestor of a binary tree. So, let's try to first understand what is there in this problem, and then we will write the code of it. So, let's start. It is a medium level difficulty. Given a binary tree, find the lowest common ancestor LCA of a two given nodes in a tree. Okay, so this is the binary tree and lowest common ancestor of a two given nodes. So from this any two given nodes, there will be given to us and we have to find LCA. According to the Wikipedia, definition of LCA is given like this. The lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. So let's first see the example. From the example, we can understand better. So this is our binary tree, and these are all the nodes 5, 1, 6, 2, 0, 8, 7, 4. So from here, the two nodes which they have given to us is pi, which is E, and Q, which is 1. So these two nodes are having 3 as the lowest common ancestor. Explanation is given. The LCM of nodes pi and 1 is 3. So previously these pi and 1 are coming from this 3. So that is why 3 is our lowest common ancestor. Let's check the second example. In this binary tree, the two nodes which they have given to us is pi, P pi, and Q is 4. Okay, so here is the 4. So here the lowest common ancestor is pi. Why it is not explanation is given. The LCM of node pi and 4 is pi, since a node can be a descendant of itself according to the LCA definition. So in the definition, it is given where we allow a node to be descendant of itself. As we can see, these pi and 4, these both are coming from this pi, and descendant can be a node itself. This node can be called a descendant itself because from the definition it is given. So 4 and 5, and we can see 4. We have to check for the two nodes. So 4, 5, and 4. So these two nodes are coming from 5 is coming from 5 itself, and 4 is coming from 5. So 5 is our lowest common ancestor. Okay. So this is the problem which is given to us. Let's try to solve this by writing the code. So what we can do is first definition of binary is given, where class P node is there, and in it there is self dot where x is the given to that val, then left is none, right is none for the construction of tree node. Then we will write the solution, class solution, and the function name will be lowest common ancestor, which we are going to find. And what are the requirement? Cell will be there, root, the root of the binary, and P and Q. This will be the root. P and Q are passed in the as a parameter. So let self dot a and s is equal to In this, we will store our answer. First, it will be none. Next, what we can do is we want to traverse, define DFS, and here node will be required. Each node, this 3, 5, 1, 6, 2. And the base case will be if node return false. If node is not there, then where we will traverse? We can't traverse. That is why we will come out from the depth first search. This was our base case. Next, now we have to traverse. Okay, so left DFS, node dot left, right is equal to DFS, node dot right. So here we will move from left and right by these two lines. And we will take a more CUR curve around and we will check node is equal to B or equal to Q. And one condition will be there if left and right or left and current or right and current from this if any of the bracket is coming true, then we will make our answer as that node, and then we will return from there, and we have to return that number also as the output is given 3 for returning, and our answer will be there in the left, right, and so left uh, or right or current. Okay, this is done. And lastly, we have to write DFS and pass root in it. And after that, the main lowest common ancestor method, we will return self.ans. Self dot, we will return our answer. I think this should do the work for us and give us the solution. Let's run and see because yes, it has worked for us. All the cases are green, green tick, and they are in green color. That means our code has worked for all the three cases. And let's submit it. So this is the solution for the lowest common ancestor. We can improve this, but this was what I have wrote down. But you can write more efficient code, which will take less time and space. As we can see during the submission, many of them have wrote the code which were took less time and overranking is somewhere over here. So yeah, more efficient code could be written. So this was the code for this problem. Okay, I will explain once again what is going on in this code. First, we have wrote down the function name lowest common ancestor, and we have took the parameters, input parameters as root, which will be our binary tree, top node, which will be the root, and P and Q. And first we will take the set of answer, which where we will store our answer, and first it will be null. And for traversing, we will make a DFS function, and first our base case will be if the node is not there, then what we will do, we will not traverse from here and there. So that is what it is done in first and second line. If not true, return false. Then in the next, left is equal to depth first search, node dot left, and right is equal to depth first search, node dot right. Here what I am doing is I am doing a recursive call so that we can traverse from this left hand side and right hand side and check the node is equal to P or node is equal to Q. If it is, then we are taking the condition left, if left and right or left and current and right and current. If from this any of the brackets are coming true, then we are making the answer as that node and we are then coming out from the depth first search. Because we have found out our answer, so we will come out, return, and finally we will return whatever was there in the left, right, or correct, because we have to print the output number, output value. That is why return left or right. And after that, we have passed our root because depth first search require any node, so we have passed the root node. And after that, lastly, we have returned the set dot answer to get the answer. So this was the working of the code. Hope you guys understood what I have written in this code. So that's for that's it for this video, and let's meet you in the next video. Till then, bye bye. Take care.